Now, the second of Babbage's contributions to this story, and really the more important contribution, is something called the analytical engine. And this, unlike the difference engine, was not actually constructed in Babbage's lifetime. And it is, to some extent, Babbage produced thousands of pages of notes and design drawings and so on in service of this idea for an analytical engine. But he never managed to actually build such a thing, or to, I think, even get the specification of how it would be designed precise enough that such a machine could be built. So nonetheless, he got precise enough in his conceptualization that this idea was influential. It was known to other developers of computer technologies in the early 20th century. There was a very a well-known piece of writing about it, a kind of introduction to the idea of the analytical engine, produced by an Italian thinker, actually, Manovrea, and then translated by Ada Lovelace, a collaborator of Babbage, that we'll say more about in just a moment because her story is kind of interesting. And that was coupled with really 3 times as much material as the original Italian article, that material being produced by Lovelace herself, who gave a lot of context for what the analytical engine was and the kinds of things that it could do. But basically, one way to think about what the analytical engine is it's an effort to generalize from what the difference engine could do to a broader range of mathematical problems, and even potentially non-mathematical problems, because in a way all the analytical engine was a machine for symbol processing. And so there is a diagram here. This comes from actually a graphic novel that was produced by Sidney Padua, which tells the story of Ada Lovelace and Charles Babbage and their development of, in a way, sort of their invention of the computer here in the 1800s with the idea of an analytical engine. But a number of features of the design of the analytical engine are certainly worth noting. So one is that we have basically 2 parts to this machine, and separating out these 2 parts is itself a tremendous conceptual innovation in terms of thinking about what a machine like this might be able to do, and how to build it. And these 2 main parts are what's called the mill and the store. And that choice of terminology came to Babbage from basically existing textile manufacture, where you would have a part of the textile manufacturing process that would be actually processing materials. For instance, looms would be weaving materials. But then you also would have a place where raw materials would be stored, and also intermediate products of the processing that had happened in the mill would be stored. So, garments that had been woven but hadn't been finished in a certain way would be kept in a place in the store and then would be returned back to the mill for further processing, or a different part of the mill for further processing. And so Babbage thought about this calculating machine that he was designing as having 2 parts in the same way. That there was a part that did processing. Today we might call it a processor. And there was the part that stored either input data, or data that had been input in some way, or data that had been already processed in some way by the mill, by the processor. Okay, and so the store is kind of like what we would today call memory. And there would be some kind of transfer back and forth between these 2, so that more complex calculations could be carried out through, taking something from the store and processing it according to certain instructions in the mill, and then returning that back to the store, because perhaps the mill needs to be used for other processing in the meantime. But then those things could be retrieved. The things that had been put in the store earlier could be retrieved again and processed in a different way, and so on. You can see how dividing up the labor in that way in a machine would allow for much greater flexibility and breadth in terms of the types of problems that it could handle. And another really remarkable feature of Babbage's design is his choice to use punched cards as input and output in this machine. So the idea came to him pretty evidently from reflection on the functioning of the Jacquard loom, which had been invented in 1801 and had revolutionized textile manufacture. Basically, this is an automatic loom. And what's really amazing about it is that the patterns that are woven, because you think about weaving fabric, it involves basically lifting up fabric that comes across in one line and slipping in fabric that runs perpendicular to it, and then doing that again and again in a kind of weaving process. And the pattern of the weaving is what generates the visible patterns on the surface of fabric. Right? Because if you loop your black thread over 3 or 4, 3 or 4 strings, or 3 or 4 white threads, let's say you loop one black thread over 3 or 4 white threads, then that makes more of a black appearance on the surface in that part of the cloth. And so it's those patterns that produce say the image of a flower on a cloth. And before there was an automated process for producing such patterns, like the Jacquard loom, individual weavers had to actually, meticulously weave the thread together to make these patterns. I'm sure that there were various ways to make that more efficient, but the Jacquard loom really increased the efficiency of producing patterned textiles because Jacquard had the innovation of using punched cards to guide whether or not certain threads would be lifted as the fabric was being woven. So if you wanted those 3 white threads to be lifted or not to be lifted at a certain point in the pattern, that could all be communicated to the machine through the punched cards, it was a mechanical process. Okay, so the punched cards would be sort of drawn through, and a hook would either go through a hole in the card or not go through the hole in the card, and then the hook would either pull up a string or not pull it up, based on where the holes in those cards were. And so an entire pattern that you wanted on a piece of fabric could be pre-programmed through basically punching these cards according to a certain according to the pattern that you wanted, and then those cards would communicate to the machine, to the Jacquard loom, where to weave threads between one another to produce the pattern in question. Now, I've gone into such detail about the Jacquard loom, of course, only to give some context for this idea of punched cards. Babbage's idea with the analytical engine was to basically communicate to the machine what processes it was supposed to carry out, and for instance, when it was supposed to take material from the mill to from the store to the mill and vice versa, through the use of punched cards in the same way. So just like the loom communicated the precise pattern with the use of punched cards, the analytical engine would be able to carry out a wide range of computations, really any imaginable computation, so long as that could be communicated, the precise pattern could be communicated, pattern of operations could be communicated to the analytical engine in the form of these punched cards. Before moving on from Babbage, I want to say a few words about his collaborator, Ada Lovelace, who again wrote really some of the only published material about the analytical engine during Babbage's lifetime. And she worked closely with Babbage in producing that text, and even played a part in specifying early on some of the possible programs that could be written for such a machine. And so some historians have called her the first computer programmer for that reason. And Dasgupta has some things to say about that interpretation, which he's a little bit hesitant about, partly because of the extent to which she was likely collaborating with Babbage. And she also was one of the first really reflective theorists about what computers were and what they could potentially do. And so she has some interesting reflections there that will later be cited by Alan Turing, that we'll meet shortly, about whether we could say computers are intelligent or unintelligent, given that they only do what they're programmed to do. And so if there's not a choice, if they're not making a choice in what they're doing, but their actions are determined by their program or their programming, then does that suggest that, as impressive as they are, they're not actually intelligent? Anyway, I don't want to say too much about Ada, but clearly a very charismatic figure. She was the daughter of Lord Byron, the famous Romantic poet, and this is this is the Romantic age, so there are a lot of kind of extraordinary stories like this of people. But she died at the age of 36, and her father, Lord Byron, also died at the age of 36, so died young. And they never met, but they kind of wrote about one another. So that's Ada Lovelace, clearly a really extraordinary individual and important contributor to the history we're talking about.